Okay. So I was saying we need to consider the use of the chain rule, okay, the chain rule to solve some questions under differential calculus. Maybe the most important question should be, in what nature of questions do you need to use the chain rule? Okay. I should be quick to indicate that the chain rule is only used where the power rule cannot do. When you look at those times or those instances where the power rule fails, then you need to introduce the chain rule in those instances. So that is what actually happens. So a chain rule only is only used in the instances or in the times when the power rule fails. That's when you use the chain rule. So now about the chain rule. So whenever you're given expressions, okay, in the parentheses, let's say you're given the questions of the form y is equal to ax raised to the degree n plus b raised to the power, let's say a over b. As long as this power here is not actually equal to 1, the a over b, this power is not equal to 1, you use the chain rule. I'll show you the examples. So if this power, the exponent, is not equal to 1, you use the chain rule. And again, if you have a situation, for example, you have in the expression ax to the power n, sa plus b raised to the power, a, where this a, the power, is actually greater than 1. As long as the answer, the power is greater than 1 or not equal to 1, get it that as long as the power is not equal to 1, in these cases, you use the chain rule. I'll explain, don't worry, I'll make you understand. Then from there are also the questions of the form you're given, let's say y is equal to the square root of, let's say ax raised to the power n plus b, right? As long as the expression that you're given is under a root, it may be a cube root, it may be a fifth root, or any root. As long as it's just, given a root, it's under a root, you use the chain rule. So in summary, whenever you have the questions that are in the parentheses, the expression is in the parentheses are these brackets, okay? You call them the curly brackets, but these are parentheses, that's how they are called. So, or is under the root, okay? It may be a cube root, a square root, a fifth root, a fourth root, whatever number of the root. As long as it's under a root, please, you use the chain rule. Is there a question on the instances where you use the chain rule? There are just two basically. There is this one and this one. Please, you have a question like this one, apply the chain rule. Any question? Is there a question somewhere? Oh, there is no question. Okay, let's start writing down. Let's have an example and let me just state what it states. So the chain rule states that if you're given a function y, let's say ax to the power n, right? Minus, b raised, let's say, to the power a over x, such a function, then the dy over dx, or the derivative of this function, shall be dy over dx equal to dy over du times the du dx. This is what it states. Don't worry, you understand. So I am saying this is what the chain rule states. dy over dx is equal to dy over du times du over dx. Is that clear? It's just a formula. You will understand the formula. Do you have any questions so far?
No question.
Okay. I'm hoping that you're writing somewhere. So follow nicely. So this is what you do, and write this one somewhere. Just write it somewhere. Okay. So now let's have a fraction. Let's have let's have an equation here. Let's say we have an equation y is equal to 3x squared minus 4 to the power 5. Okay. I've told you that the power, as long as the power is not equal to 1, you use the chain rule. So now, the first step that you are supposed to do, step number 1, is to name the expression in the parentheses as u. So you say, let u equal to what? 3x squared minus 4. Is that clear? You are creating the u function. Okay. So let u equal to 3x squared minus 4. Is that clear? Then if this becomes u, then you have your equation being y is equal to u to the power 5. Isn't it? Where there is this expression, you replace by putting u because you have said that it is equal to u. Is that clear? People are not following Vasa, they are not responding.
Yes, we are following.
U over the x is equal to dy over du times du over the x. Yeah, I've just decided to write the formula here down so that you are able to follow. So now, observe that we have now how many functions? 2 functions. We have this one and this one. So we need to start differentiating these functions, okay? We need to start differentiating these what? This function. This first function, this one, is called the u function, okay? Because the first letter is the u function, is u. So like the function is like this, u is equal to 3x squared minus 4. So we need to differentiate this u function with respect to x. Now, the differentiation of a function with respect to x, since this is a u function, you shall call it du over dx. Why are you saying du over dx? Because this is a u function, is being differentiated with respect to x. Clear?
Yes.
Okay. So now, from what we said last time, we can now differentiate this function with respect to using power rule, because this is now a straight line. Yeah, it's a linear equation. It's a quadratic equation, actually. You can use the power rule. What is the derivative of this function? How do we differentiate? What did we say? Faith, do you remember what we said? Okay. I said first thing is to drop the power, isn't it? You say 2, drop the power 2 times 3 x to the power. This power reduces by 1, so it will be power 2 minus 1. That will just be 1. And I said the derivative of a constant like this, as long as it's a constant, to be constant simply means it doesn't have any letter, it's 0. Do you remember something like this?
Yes.
From the power rule? I implore the class to follow nicely and ask questions where you're not clear. Please, can you ask your questions if you're not clear? Okay. We assume that since you're not asking the questions, you are okay. Which one is which? Is it that you are more confused or you are fine?
Me, I'm not confused, but I'm following. Since last time, I didn't attend class, so I'm following. I'm trying to catch up.
Okay. Right, but I shared the recording that we had for the previous class. You didn't follow through it as well. So it's important that when you miss class, please, we share the recordings. You also have time to go through it so that you can catch up, right? Before the next class. Very important. Okay, so what is 2 times 3? That gives us 6x, right? Plus 0, that's just as good as 6x. So therefore, du over the x is equal to what? Is equal to 6x. Is that clear?
Yeah.
Okay. So now we have differentiated the first function. We need to differentiate the second function as well. The second function is this one. Okay. This one is now a y function, right? It's a y function differentiated with respect to u. So therefore, it will be called dy over d what? Du. Is that clear? Because the variable is what? Is u. How can you differentiate this using the power rule? U to the power 5. Just like what we have said previously, drop the what? The power. So it shall be 5. We know that there is the invisible one here, times 1 u to the power 5 less 1. We deduct 1. Then you have 5 times 1 giving you 5 u to the power what? The power 4. Is that clear?
Yes.
This is the dy over du, right? This is our dy over du, or the derivative of the y function with respect to u. So it's giving us 5 u to the power t to the power number 4. Is there any question from anyone? Right. From here, it becomes very easy, yeah? Because you already know u, right? In this function where there is u. Do you remember u? You know u? I've said that this is your u. So where there is u, we are going to put what? The value of u, 3x squared minus 4 to the power 4 as our dy over the what? Du. Right? Where there is u, we have put, the value of u that you said is the value of u. Is that clear? So after deriving, after differentiating, you put, the value of u that you had assigned that, yeah, that's the value of u. Then from here, it's very easy because you need to get now your formula and start substituting, right? Into your formula. So your formula says it's dy over du times what? Du over dx. So let's write down. Let's write down now. What is dy over du? Dy over du is what? Is 5. Open the bracket, 3x squared minus 4 raised to the 4th degree times. What is du over dx? Anyone to tell us what is du over dx? If you are following. Du over dx is equal to what? We've just solved for du over dx. You can see it right at the board. What is du over dx? You guys, you can't see the du over dx? Anyway, we said that du over dx is equal to 6x, right? That's what we solved. We have solved that du over dx is equal to 6x. So we just bring 6x like that. That's very simple as it is. So when you reach there, then you're about to finish writing. If you want, you can start multiplying these numbers like this. 5 times 6x, so that you can have 30x, multiplied by 3 squared minus 4 to the power t, the power 4, 61, and the same thing. This is where it ends from. Any question?
So no need of multiplying inside.
No, you cannot, because no, you can't, because these are 4. This simply means to the power 4, it means that 3x squared minus 4, it multiplies itself 4 times. Like, this is a very huge expression. So it's better you just leave it like that. That's when you can manage it. You got it? That's about the chain rule. Is there any question about this? Okay, we pick the second example. Let's pick example number 2. You should follow through this recording again when we are done. That's but you should be asking questions. The question is y is equal to, the third root of 4x squared plus 5x. How do we go about this one? Anyone with an idea? What would we do? Or maybe I should ask like this: what is the name of the root? This root. Is this the second root, the third root, the fourth root, the fifth root? What's the name of the root? Hello? What is the name of this root? Okay. You don't remember the roots. Anyways, we said that if you have a number like this one, the power 2 here, it is called a square root. Okay. But if you have a number like this one, then you have a small 3 here. It is said to be what? A cube root. It's a cube root, a third root. Then if you have a number like this one, this is called a fourth root, a fifth root, just like that. So now I ask the question one more time. What is the name of the root that you're dealing with?
Cube root.
All right, thank you. So this one is a cube root, okay? Or the third root, if you may like. So for that reason, you can still rewrite the third root as y is equal to 4x squared plus 5x to the power 1/3. It's still one and the same thing. See, just one and the same thing. Just like the square root, you learned that under indices, the square root of a can still be written as a to the power 1/2, right? This is what you learn under indices in grade 9 somewhere there. You learn this, that the square root of a is equal to a to the power half. It's just one and the same thing. So this is what we are trying to show you. So if again you have the third root like here, this will just be equal to a to the power 1/3. So this is what has occurred here. We've just rewritten the the expression. Is that clear?
Yes.
So now let's pick the expressions. First, we need our u. Our u will be equal to what? 4x squared plus 5x. Please remember power rule that we discussed previously so that you are able, every time I teach you something, you should understand, because the next time we'll be building on top of what we have covered. So it's important. That's our u. Then our new equation will be y is equal to what? You replace here with u. So it will be u to the power 1/3. So what we need du over t over the x, meaning differentiating this function with respect to x. What is the derivative of this function with respect to x?
It's 8x.
8x. Is that all? Yeah, so you drop the power 2 times 4, it will be 8 what? 8x plus 5, isn't it? It will be 8x plus 5. That's du over the x. Let's get dy over, dy over du. Dy over du. Why are we calling it dy over du? It's because it's a y function being differentiated with respect to what? To u. So you drop the power, it will still be 1/3 u to the power negative negative what? Negative 2 over 3, right? When you deduct 1, like you say 1/3 minus 1, what do you find? You find the negative 2/3. You have a question?
Yes.
Go ahead.
Here on 8x plus 5. If I recall, the previous one we say you said it was something like 6x plus this. The last one was a constant. Which one? It was 0. It was 0. The last one. So out of this one, is it?
This one is not a
supposed
constant. It has a variable. The previous one never had a variable. It was just a number. So this one it has a variable, at least raised to the power 1. So as long as it has a variable raised to the power 1, then you pick the coefficient. That's what we said last time.
Okay.
Okay. Are we okay up to here? Mathematicians, you are okay? You guys, you solve mathematics. Yeah.
Yes, we are
We want math to be made very easy. Faith, do you have a question?
No.
Okay. So now we can go ahead and then we rewrite this one. Let's rewrite the u function. So the u function, the dy over du actually, dy over du can be rewritten as 1 over 3. Okay. We can still rewrite this function as times u. Let's rewrite this one according. It's only that you have forgotten the indices. I see. Most of you have forgotten the indices, but that is still okay. Don't worry very much. 2 over 3, like that. So that when you multiply 1 times 1, it can give you 1 over 3 times u. It will give us 3u to the power 2 over 3. So that is to say this whole expression will be written down as what? As 1 over 3, okay, u to the power 2 over 3. Just like that. And you and I know u, right? We have found our u. We said our u is this. We need to replace u so that our function can be 1 over 3 times 4x squared plus 5x, we close to the power 2 over 3. This is your dy over du. This is your dy over du. It is supposed to multiply with what? Du over dx. Then you find your answer. So let's multiply the two functions and substitute into our formula. What is dy over du? Our dy over du, we said, is 1 over 3, open the bracket, 4x squared plus 5x, closing, have 2 over what? 2 over 3 times, what is du? I'm here. Du over dx. You said it is 8x plus 5 over 1 if you want. So basically, it's just to replace, okay? Nothing much to be done, but just the replacement into the formula. You can do the multiplications on top, and then you'll be able to find that 1 times the whole expression, it will give you 8x plus 5 on top, over in the denominator of 3, open the bracket, 4x squared plus 5x to the power 2 over 3, like that. And you're done. Simple. Any question? Is there any question? Faith, do you have any question?